92 to say like why
91.
one is which one? So
91.
application, which one?
91.
91, application, it was number 2?
Yes.
Alright, so delta S is what? What is S?
Entropy.
Entropy, so that is disorder. So if it's positive, delta S, does that mean entropy is increasing or decreasing?
Increasing.
Increasing. Alright, so if it's going from a solid to a gas, is it increasing or decreasing?
Increasing.
Increasing, because you're going from a solid with locked in to a bunch of pieces moving around. So that's why that one is increasing. Alright, B, so you're going from a liquid to a solid.
Decreasing.
Decreasing, because the molecules are moving on each other, they're locked in, so there's more order.
C is where I get confused.
Alright, so you have a solid, gas, and then a gas substance. So it also has that if you have it to where you have the number of particles decreasing, because how many particles do I have on the reactant side?
3.
Alright, 3 gases, and then with a solid as well, so 4 total, and it turns into how many molecules of a gas?
1.
1. So you have 3 gases plus a solid, 3 gases turning into 1 type of gas. That's why that one's going down. Yes, so that one's decreasing. Alright, C, do you have a question about that? I mean D, do you have a question about that one?
I don't think so.
Okay. Do you have any questions about any of the others, or does that answer all of it?
Can you do D, and then that should be good.
Alright, D. So I have 1 solid, 2 solids, and then a gas and a solid. Alright, so I have 2 solids and then a gas and a solid. So which one has more disorder?
The gas and the solid.
So is it increasing or going?
Increase.
What?
Increase.
Yep, increase. Okay, you got it? Alright, Chris, you had a question about the equation. Was it anyone specifically? Alright, so super fast, then we'll just go through it. Alright, so if you're working with the first law of thermodynamics, so delta E, what's the equation for that one? Alright, Q plus W, you gotta know them. Alright, so
Yeah.
will this one be positive if heat is being put into the surroundings around it? No, so it'll be negative. So this one, if work's being done on it, will it be positive or negative? Positive. So you just add them up together. We'll see, okay, which direction is it going, and then add it up together. So any question about this one? Alright, the next one. Alright, the next major one has to do with finding specific heat. Remember the equation for specific heat? It's making me real nervous, Chris. Alright, C equals Qm delta T. You can also change it to find Q if it's Cm delta T. So this is the same equation, just depending on what you're finding for it. So algebraically, just move it. So if you find heat, you want to use Q by itself.
And then specific
If
heat.
you want to find specific heat, you put
I
those
thought the
together.
one with specific heat was C equals Q and delta T. Or
This one?
yes, that.
Okay, remember, what's Q for?
That's heat.
Yeah, heat. So
But
you want to find heat by
On one of
itself.
them, it said you were finding specific heat, and it had that.
If you're looking at the bottom page 81, that's where it's talking about, okay, yes, typically if you're working with specific heat, sometimes you gotta find just heat in and of itself. So it's kind of saying you use this equation or a modified version of it. Alright, if you're working with a calorimeter, what type of equation do you use? Alright, but yeah, so you don't give it in this form, so what do you use?
Negative NT delta T.
There you go.
And then positive.
And you just plug in all of your variables for it. So this is for a calorimeter. Alright, what if you're going from one state to another? So, try to make sure Demi can see as well. So, Q of fusion. What's the equation for that one?
It equals. I don't remember this one.
Alright, so Q for fusion or heat of fusion, it's M delta H fusion. So whatever it is, like if it's 334 joules per 1 gram of water, it's how many grams of water, just multiply
So
times it.
that's when you're trying to find heat of fusion.
Yeah, if you're trying to find heat of fusion, or if you're finding heat of vaporization, what's the equation for that one?
Same thing.
Yes, the exact same thing. You'll be given that. I'll tell you what the heat of vaporization or heat of fusion is. So just let's see, okay, if this is the heat of fusion or heat of vaporization, okay, I just multiply how many grams I have by it. Done. Watch my units and I'm okay. And stick fix. Alright, anyone have any questions about that one? Alright, keep in mind, if you're going from a solid to a liquid, will this number be positive or negative?
Positive.
Positive. What if you're going from a liquid to a solid?
Negative.
Negative. Just be careful. Check for that. Alright.
Wait, the H would be negative?
But because it's the amount of heat, like, lost as it goes.
Or would it be M delta, negative delta H? Or would it be M delta negative H?
It's negative H because you can't have like a negative grams. Alright, Gibbs free energy, so delta G equals
H.
delta H.
Minus T
T
delta
delta
S.
S.
There you go. And what does this have to be? It's gonna be spontaneous.
Negative.
Negative, it has to be negative. I think that's all the equations, so does anyone have any questions about any of them?
I think so.
Can you leave them up there?
What?
Can you leave them up there?
So the answer has to be negative, that's what you're saying.
Yes, if it's a positive number, it's gonna be non-spontaneous. So if it's gonna be spontaneous, it has to be negative.
So
Has
if
to
it says you get the Gibbs for energy and then it says it's a spontaneous or
Mhm. I'll ask you.
non-spontaneous, then if it's non-spontaneous, it's positive.
Yes,
Yeah.
and then I'll give you partial credit for that one too as well, so based on your answer.
So even if I don't get the answer, I just put spontaneous and have
Okay,
the
well, I
answer.
mean, if your answer is a positive number and you write spontaneous, I know, oh, and he at least got the concept, so, I mean, his answer's still wrong, so he's losing partial credit, but I'm gonna give you at least partial for you, okay, you have the right idea, I
keep
know
that.
what you're doing for it. So, negative number, always spontaneous, positive number, non-spontaneous. Alright, what is, temperature at standard state?
298.1 bars.
298.15
1
Kelvin,
ATM.
it is 1 ATM, good job. Alright, I think we covered everything else yesterday. Just wanted to make sure,
Just show on the road.
yeah, I'm pretty sure you did. Alright, so let's go ahead and I'm gonna give you as much time as possible. Alright, so I'm gonna go ahead and pass it out so I can give Jamie the instructions at the same time for it. Everyone, and Jamie as well, you should have this little bitty chart with the different, with the standard heats, the formation on it. And have any questions? We gotta go. Try to cement them. So yeah, it'll say on the question which one you need for this. Please don't mark these because they're a pain to make and I want them back. So as much as you can, Jamie, try to get it back to me as best you can. So gentlemen, do not mark on these because they're a pain to make for them. So you're each gonna get one, and then here's your test as well for it. Alright, so let's go through the instructions. That first section is literally just a 50-50 shot. If you have no idea, just guess. So in the space provided, tell if the description is describing as endothermic or exothermic. Just describe it as best you can as you're going through it. Matching section, you've got to know your symbols. You have to. So choose a symbol on the right that corresponds with the term on the left, and just maybe use once, more than once, or not at all.
That's a
So
free
this is
section.
what you're doing. What?
That's the first section.
Yeah, basically, it should be helpful, but it's one of those, just be careful. Alright, modify true false. It's a little bit trickier. Did you write false anywhere in there, Quentin?
Yeah.
No, do not write false. So the statement is true, the statement is false, change it, fix it. Alright, completion of the space provided, write the words that answers the question. Be careful to what you're doing. Like, for 27, it's asking what is the pressure and temperature at standard state, so be sure that you put both answers down there. And just read through it. Like for number 30, it's asking what common state of matter has the most entropy. So make sure that you're thinking through, okay, what am I doing for it? Alright, then the rest of it is pretty much your math section. So show me your equations, so that way you can figure it out as best you can, get partial credit for that, but then also just think it through. Pay attention to units and sig fig, show all of your work so I can give you partial credit. Alright, number 34, that's the one where you need the handout for. So make a note for that one, that's the handout for it, so just look at it in the handout and be able to figure it out. The rest of it is pretty straightforward, just read through it.
An essay?
Which ones do you need to hand out for?
Number 34.
No essay?
There's no essay because of how much math is in this one.
Just 34?
Yeah, just 34. The rest of them you don't have to have it. So you do your calculator, but that's it for it. Calculator and pen, pencil if you want to do math and pencil, and go back and pen, but make sure your final answer. Alright, anyone have any questions?